All right, welcome back to week 4 summary class. And we are going to discuss about inheritance. So inheritance is a concept which is coming out of object-oriented programming. It is one of the principles. It basically means that the properties of a parent class will be inherited by the child class. That is all it means. The properties of the parent class will be inherited by the child class. Now, question comes, why do I need to share my properties with the child class? Lot many people, they struggle to understand the actual requirement of inheritance. Like, why do I even need that? Okay, in programming space. That is exactly what I will be discussing today with you. I will take the example of car and then we will complete that. All right. So let's create a new project here. So week 4 summary class, and don't create. And under this new package, let's say cars package. Okay. Inside the cars package, let me close everything else. Inside the cars package, I'm going to create a new class. And let's call this class as car class. Simple. Basically, what I can do is I can copy the entire content of car. Actually, I'll remove this from here. I'll copy the entire card from here and paste it here, okay? To save time. Good. This is my simple car class, as you have seen this. So that's cool. Now, as a part of this particular car class, I have some methods like getters and setters. That's right. But the main method which I will be more interested about is the print car info. That is the right method that I'm mostly concerned with because it is a little bit unique. It is giving me all the information about the car, right? Leave about these methods. These are just simple getters and setters, and we have used that so that I can work with privates, right? If I even say this private, then I have a getter and setter for all of them, right? So leave that part. But what I'm trying to say here is that we can give some more methods over here. As a part of the car class, a car can be started, a car can be accelerated, can be stopped, correct? So let's give three methods to it, three properties to it. So public void start car, and I'll have another one, public void stop car, and accelerate, public void okay. Now the point is that let's create nothing but a sysout. Okay, and all I'll do is I'll just say brand plus model, brand plus model, one, my keyboard is acting funny. Hold on. Okay, so let's say starting. Okay, simple, started, right? Let me or the starting, correct? And let's then we'll do a simple stop car, stopping. Okay, and then accelerate. Something like that. See, I don't know what happened to this stupid keyboard. Bluetooth keyboards are good, but at times it really acts funny. Hold on. Okay. Okay. So it's a good thing. Okay, good. Now, this is my simple car. Good. Let me create a car controller. New class, a car controller, car tester. Let's give it car tester, main method. As a part of car tester, I'm asking you to go ahead and create an object of Mercedes. Create an object of car named as Mercedes, enter Mercedes details, and start, stop, and accelerate. We can do that, no problem at all. We can just say car, just a Benz, new car, and then we say Benz dot set brand, Benz dot set model. Okay, let's just add these two. Other things not required. So I just say brand is what? Say, okay, model E350, something like that. And let's go and start the car. We can do that. Benz dot start car. Okay, Benz dot stop car or accelerate car. Okay, and Benz dot stop. You know very well that if I run this, what will happen? It will simply print out whatever we are expecting, right? No problem at all. If I go ahead and create any other object in the car tester, any other object, let's say, let's create a Mazda or Audi, right? And we can do the exact same thing, Audi dot set brand, which is Audi dot set model, which is A3. Okay, Audi dot start, Audi dot accelerate, Audi dot stop. You can do that, and all the time it will work flawlessly. See, everything works perfectly fine. The question comes, how do I get a situation handled where I want my child objects, or let's not say child objects from here. Let's say we have created a car template. We have created a Benz out of it. We have created an Audi out of it. Whenever I'm running my program, For Audi and for Benz, we are actually getting same type of output. The type of the output is exactly same. Starting, stopping, accelerating. It is exactly doing the same thing. But how is it possible for me to provide a unique feature to Benz, which is only going to be unique to Benz, and same for Audi, only going to be unique for Audi? How is that possible? Is it possible? Because if I want to give a new feature, for example, I want to, Benz E350 is having a new feature, which is as soon as you go in front of the car, you're carrying your car keys in your pocket. As soon as you go in front of the car unlocks and probably starts, right? So we can say a proximity sensor, right? With Audi A3, you don't have a proximity sensor, but you have a security feature that it needs fingerprint scanner, fingerprint scan, right? It needs a fingerprint scan for you to open the door and start the car, right? How do I provide these two unique features to these two cars? How is that possible? Because if I somehow add the proximity sensor to car as a template, or fingerprint scanner to a car as a template, then this template is going to be always producing something that is available to the complete category, the complete objects, right? It will be always available to the complete object, all the objects. As soon as you put a proximity sensor to a car, it will be available to both Mercedes and Audi. You're not going to have an unique feature. You understand? You're not going to have an unique feature. So if that's the case, if you have to handle a unique feature, keeping everything else shared, then that's where inheritance comes in. So let's look at the plan. The plan is very, very simple. The plan is that we have a car class. As a part of the car class, we have start, we have accelerate, and we have stop, right? We have these three things anyways. So you create an object of the car class. Every time you will have access to the start and the stop and the accelerate. That's fine. But how do I provide a unique feature? I can provide a unique feature if I can create a subclass or a child class, something like this. I created that. Look at it. I'm not creating an object yet. I'm creating another class, another two classes. And this is going to be for Benz and for Audi. I'm creating these two classes, which are absolutely independent to each other. And then what am I doing? I am going to inherit everything that is coming from car to both of them. Why it is needed? Why do I have to inherit? Because car is the class where you have your primary variables or primary attributes, meaning your brand, your model, your seating capacity, your engine, your seat, right? Everything is described here in the car class. So I don't have to really recreate them in the Benz or in the Audi. All I have to do is I have to inherit the properties of the car class. As soon as you do that, obviously you will be inheriting the entire attribute set, as well as you will inherit these three methods as well. But now you can also, the Benz class can also create its own property, and that will be start with proximity. Start with proximity. Do you understand? Or start with fingerprint. Fingerprint. Now, this strategy is going to work out in a way where you are keeping things unique to yourself. You're keeping things unique to yourself by extending things from the parent class. This is the situation where you will use inheritance. Is this concept making sense? This is the first thing that I should be concerned about, because a lot of people, they don't even understand where to use inheritance and why to use inheritance. So this will be an ideal situation for you to raise a question if you don't understand this. Any questions? Ahmed, any question? Raman is good.
No, yeah.
Okay, good. Bongi, are you good?
Yes, I'm good.
Okay, perfect. Afi, is it making sense? You're mute, Afi. If you're there,
Yes,
yeah. So is it making sense?
yeah, I understand it.
Okay, good. Thank you. So let's move on towards its implementation. How do I implement this? It's simple. As I said, I need to create two more classes. Number one, it's going to be for Benz, new class. Let's name this as Benz or Mercedes. And I create another class, new Audi. I created these two classes. Good stuff. Now what do? I have to create the relationship between the parent and the child. How do I do that? Simple, extends. Extends who? Car. Car. Audi extends car, or Mercedes extends car. Right? Right? Now, I won't do anything. I'll go back to the car tester. Okay? I'll remove or I'll comment out whatever I wrote earlier. And then I'm going to create a new object of Audi. Let's just say that. So Audi equals new Audi. Correct? And now you'll see something. You'll see if I do Audi dot, right? You immediately will see that the Audi object is having the access to accelerate method that is coming from the car class. Look, it is showing you. The Eclipse is showing you that accelerate is a method which is a part of the car class, and Audi can access it. Similarly, get brand, get engine, get model, get seats, print info, set brands, all of them, start car, stop car, everything is accessible by the Audi object. How? Because Audi is extending to car. That's where it is accessible to all of them. right? Now, the point is, even though it is accessible to all the car properties and attributes, still Audi is not having its own feature. It's not having its own feature. So how can we achieve that? How can we achieve that? We can achieve that with going to Audi class and create a method or create a new property. Public void start with fingerprint scan, something like that, right? That's a unique selling point for this car, correct? And what can we do? We can just toast this out here for the example, saying that starting car with fingerprint. Starting, let's say, okay, I'll just get the Audi, so get brand. Get brand is a method, right? Get brand plus get model, okay, plus starting car with fingerprint scan, something like that, right? That's the simple situation. Exactly the same thing I'll do for Mercedes. Mercedes is having, oops. Mercedes is having a method. It's going to be start car with proximity sensor. Okay, starting car with proximity sensor. How about that? Good. Now that I have these two unique features for Audi and for Mercedes, I can very well go back to my car tester and I can do this. I can say Audi dot set brand. And let's skip the brand because I have to give the brand, otherwise it will not print. So Audi dot set model. Actually, here it is, right? Okay, and then Audi dot start with fingerprint scan, right? And Mercedes Benz new. Okay, and then we just do the same thing here, like this. Okay, and what else? I just do Benz dot start with proximity sensor. Correct? Correct? Make sense? If I run this now, then works perfectly fine. This is called inheritance. Don't use inheritance like everywhere. Okay, everywhere, wherever it is not even required. Okay, don't think of like when I'm giving a problem to you, try to analyze the problem. Don't just think about inheritance all the time. Every problem has a specific solution, and every solution cannot be used for the same problem. So keep that in mind. Try to match the requirement with whatever I just said today about inheritance? Do you have a requirement where your subclass will have a special power? If yes, then you would go for inheritance. Do you, now the first question is, do you require a subclass? Okay, do you have a situation where you need to create a subclass at all? Because that subclass, in that subclass, you can create you can give a special power to that particular entity without hampering the parent class. Do you have a requirement like that? Ask the question to yourself and then think about it. Don't just, try to use this concept everywhere. That won't fit in all the time. So now look at the diagram. There are three different types of inheritance that we can create. Number one is a single inheritance, where you can see that class A and class B, only two entities are here. Only two entities, class A and class B. Class B is extending to class A. That's one thing. And the next thing that you can do is multi-level inheritance, where you have a class A as an entity. Class A is having a class B, which is a subclass, and class B is having another subclass called class C. So the properties of class A and class B both will be found in class C. It's exactly like we understand inheritance is, right? The properties of grandparent can be in the grandchild, something like that. So that's exactly how it is. And right now, whatever we did was hierarchical inheritance, because this was the car and these two were Mercedes and Audi, correct? We just did that. This is called hierarchical inheritance. Now, there are two more inheritance that doesn't work, that is not possible for us to establish. And these two are multiple inheritance and hybrid inheritance. Multiple inheritance, meaning one subclass can inherit from multiple parents. That is not something that is possible. You cannot inherit from two different parents at the same time. I mean, I cannot write that I am inheriting from, say, car and somebody else. I can't do that. Okay, so that is not allowed, right? One at a time. One plus subclass can inherit from one parent, and that's it. Okay, that is not possible. And obviously, hybrid is not possible, where one subclass is going to two subclass and two subclass is going to one subclass. Like this, the top part is possible, but the bottom part is not possible. This entire thing is called hybrid, not possible. Okay, so that is what you have to remember. Okay, that's with inheritance. Now we will try to understand what is constructor, a very, very important topic, which is why exactly last week I didn't enable you the new things, right? So what are constructors? Let's try to understand that. Just give me 2 minutes. And overloading. We have overriding, runtime polymorphism. Yeah. Too many theoretical things to cover up. Obviously, I'll give you practical examples, but these are very, very important. These are the building blocks. So please be patient. Just give me 1 minute, okay? Okay, so let's try to understand what is a constructor. I'll go back to the same situation of cars class. And let's try to discuss this part, constructor. So we'll go to car. Constructor is nothing but a class member. Constructor is a class member which can help you, which can help construct the instance of the class, right? Two main points or keywords that you should be focusing here are construct and instance. It helps you construct the instance of the class. What do I mean by constructing the instance? Constructing the instance basically means providing data into the data members. Providing data into the data members, meaning the attributes, which means basically these guys. Constructing the instance of the class. If you remember earlier, I have given you an example of heap memory and stack memory. This is a heap memory, and I told you that whenever I'm creating an instance of a class, whether it is a Mercedes or an Audi, they are different from each other because they have two different address space, right? This is the address of Mercedes. This is the address of Audi, right? This is Benz, and this is Audi, right? And these two entities have no connection between each other. They have their own individual existence, individual world. However, in this individual world, they are having individual world, each one of them, they are having all these class members attached to it, meaning all the attributes and all the properties are there for Benz as well as for Audi. Correct? Now, a Benz, we are understanding a Benz as a Benz because we are setting the value of Benz attributes. We are performing these actions: set brand, set model, set brand, set model. We are making them different from each other by setting the values. However, that is not the main difference between Audi object and Benz object. The main difference between Audi object and Benz object is not the data, This data is making them different from our perspective. From our perspective, these data are different. So we are thinking that Audi and Benz are different. That is not the case. They are different from each other because they have different addresses in the memory. in the memory. I can prove that to you. Let me just write something over here quickly. I'm going to say sysout, right? I'm going to say Benz dot equals Audi. Look, obviously at this stage, Audi and Mercedes, they have different data. So you must be thinking that, hey, obviously this is going to give me a negative result. It shows false, right? So you'll be thinking, hey, obviously they have two different data, so they are different. No wonder. However, if I make them same, even though I'm making them same, look, I made them same, right? And then I run it again. It's still false. Why? Because data doesn't matter. Data doesn't matter. One object is different from the other object, not because they have two different data inside it, because they are in two different positions in the heap memory. That's why they are different. Is that understandable? They have two different addresses in the heap memory. Is this understandable? Yes, no? Steve, getting it? Kester, getting it? Okay. Okay, all right. So then the point is that, let me bring back my drawing. It was here, I think. Yeah, that's better. Okay. Constructor is a class member. I will go to car class, sorry. Okay, yeah. Constructor is a class member which can help construct the instance of the class. When I'm saying that I want to construct the instance of the class, this basically means to provide data inside the attribute of the class. To provide data inside the attribute of the class. That's where I am that's where I am talking about the construction. Right now, the only way we are providing the data inside the class is by calling the methods like set brand and set model and set engine, those kind of things. That is not how we should be doing the job in an efficient manner. Our idea is that as soon as I construct the class, that means as soon as I write car car equals new car. As soon as I write this line, at the same time, I want to specify that what kind of car I'm trying to construct. Note this line down. What kind of car is I am trying to construct? Keep this line in your mind forever, which means that I am going to call a constructor here, or I'm going to create a constructor here and then call it while I instantiate my car object. How to do that? It's very simple. What I'll do is let me remove these three guys, and then Let me remove everything from here to here. Completely gone. Good. And then I create my constructor. How? Constructor is going to have a specific design, meaning a constructor will be public, all right? It will not have any return type, and it will be named after this class name. So public car, that's it, that's a constructor. And that's how I declare a constructor. Same name as the class name. This is a constructor. Basically, this is a default constructor. I am a default constructor, right? And by unknowingly, we were always using this, or we were always calling this. It's just that this guy is by default hidden. In programming in Java, this guy is by default hidden. Therefore, you didn't know that you were actually constructing the object of the car using a default constructor. You didn't know that. Okay. Look at the situation from car tester. You did write car Benz equals new car. This section over here is basically the constructor part, this brackets. So it is an empty bracket, right? Which means it is actually calling this constructor with an empty brackets. This is basically the default constructor. If I just go back to the car tester and let's just remove this. Let's go to this guy. I'll enable this guy. And I will comment out this guy. And I will just run only this one. Just run only this one, okay? Run. Proceed. Look, it is calling I am default constructor. As soon as this line was executed, if I debug this, I put a breakpoint line number 12. And if I debug this, just like that, you see, as soon as my instance was created, I landed up here in this line number 12. You can very well see that, correct? So the point is, we were always calling a default constructor unknowingly. So now let's try to fix this in the right way. What should we do? As a part of the constructor, my idea is to provide all the attributes. So we can do something like this. We can stop the execution number 1, and then we can just say string brand, string model, string double engine, and int seats. Correct? We have this 4. And then what do? I am going to just say this dot, okay, brand. I'll tell you why I'm writing this. This dot brand equals brand. Okay. This dot model equals model. This dot engine equals engine. I should restart my system. And this dot seats equals seats, right? Now, the point is, look at the situation. As soon as I created a parameterized constructor, look, as soon as I created a parameterized constructor, I cannot instantiate a car class with a default constructor. Do you see that? It's clearly telling you that the car with empty constructor is undefined. As soon as I created a parameterized constructor, I cannot use a default constructor anymore until and unless you specify it here again, like this. If you do it, then that error will be gone. Look. Okay? Until unless you specify it again. If you don't specify it like this here, then you will never be able to create a default constructor anymore. Or you will not be able to call or create the instance with a default constructor anymore. That's the whole point. Correct? Now, a few things to understand. What is this keyword? This keyword means that whenever I am instantiating an object of the car class, so this is the instance of the car class right here. So when I say this dot brand, it basically means that inside this particular object, I'm trying to access the brand attribute, because this brand is obviously a part of the car constructor. Oh, sorry, the car instance. So this dot brand means for this particular instance brand attribute or model attribute or engine attribute or seats attribute, right? That's why the keyword this is coming here. Okay. Now, let's try to make it work. We have created this, no problem. Now let's try to go back to our tester, car tester. Okay, it is complaining that it doesn't have all those information. So let's give the information over here. For example, we'll say Mercedes, that's the brand, then the model. So while I'm creating the instance, I'm providing the value at the same time. That's the whole idea, right? Of constructor. And then you go engine, I'll say 2.0 and seats 5. Now that's how I created an instance of the car class. And then what do I do? All I do is like this one. Look. Okay. If I run, obviously, proceed. Obviously, you got this value here. Why you got this value? Because I added this value as a part of my constructor. That's why you got this value, right? That is why construction is very, very important. You have to use the right constructor to construct the value. You are making sure that as soon as you're instantiating an object of the class, you are providing the values that it requires so that the instance of the class can function properly, right? For example, think about it. Earlier, we were using this. Earlier, we were using this option, like set brand, set model, those kind of information, right? Now, if a user is choosing not to call set brand you cannot enforce them, right? You cannot enforce them. You cannot tell them that you need to call set brand or set model. You cannot do that. You cannot enforce them. And if the user is missing out in setting the brand and setting the model, then the start card, the accelerate card, the stop card will show you a null value. Because obviously there is no brand, no model. So obviously when this will be running, it'll run against the default value, which is going to be null, obviously. That is not going to be the right experience for the user. When I'm saying user, I mean whoever will be using the car or the car class, right? That is the user. So whoever is going to be using the car class, they can miss out on few things, and then the class will not function properly. But with this strategy now, they cannot go around it. They create an instance of the class. They have to provide these values. I mean, they can still mess with it. They can still provide empty values. You cannot really control that. But then at least from your side, you're making sure that, hey, I'm making sure that if my user wants to use the car class, then they have just one place to provide all the values required. And that is going to be the construction part. Is this understandable? This whole situation or whole constructor concept. Bongi, Kester, is it making sense?
Yes, okay.
Bongi, what about you? Good, okay. Steve, are you understanding?
Yes.
Very good. So guys, I'll take a 5 minutes break. I'll come back. There is a more to constructor and you will see a few more things now. But let me take a 5 minutes break. I'll come back and then we'll talk from here. I will show you how constructor is going to impact subclasses. How constructor, adding constructor in the parent class is going to have an impact on the subclass. Okay, I'll show you that. So give me 5 minutes, I'll come back and we'll start from here. Thank you so much. All right, so we just have learned about constructor, but there's a very important thing that we have to understand, and that is the impact on subclasses on constructor, right? What kind of impact you will be having. So you see, I have a car class. I added a constructor over here. Okay, and I showed you why it is like that. But as soon as you added a constructor over here, now you see there are two errors showing in Audi and Mercedes. Why? Because I have created a relationship between Audi and car and Mercedes and car. Okay. Audi extends car, right? So you create the inheritance with the keyword called extends. I told you that. Now the point is, that this Audi is having a problem now. What problem? Audi is saying that, hey, implicit super constructor car is undefined for default constructor, which means it is basically saying that in the car class, there is no default constructor there, which means Audi's default constructor will also not be acceptable. Rather, you should add a constructor, which is a parameterized constructor like this. Look, it is clearly telling you that because my parent class, because Audi's parent class is having a constructor in place, therefore Audi, which is a subclass, should also respect that constructor of the parent class and create its own constructor. And that makes sense. Think about it. When you are creating an object of Audi like this, Audi equals new Audi. Think about it, right? New Audi, right? Now, if you are not passing any information here, if you're not passing the brand or the model, right? Or the model or etc., right? If you're not passing this information, then how come these information will be sent to the car class attributes? Because car class is the car class. Oh, sorry, car class is the class which is actually the class who is holding the primary attributes, right? All those models and the engine, all those data members. Those data members are not part of Audi, right? They're part of car. Now the car class should have those information. Otherwise, how are you going to send those or set those information there? So somehow the other, you have to figure it out. How can you, I mean, this is how you will be passing this information back to the car class. Otherwise, you cannot do it, right? Otherwise, you cannot send those information. So that is why it is very clearly telling you why it is complaining. It is saying, how are you planning to send those information to the car class? That makes sense to me. So look, here in the Audi class, you have 4 parameters: brand, model, engine, seats, correct? 4 parameters. Think about it. Audi brand is always going to be Audi. So there is no really point for us to, while constructing the Audi brand, there is no point for us to really give this parameter at all, because this is like a constant. It is always going to be constant. So if it is always going to be constant, instead of adding brand as a part of the Audi constructor, we can simply remove that. Meaning we can simply remove that like this. Okay. And then simply hard code the value over here like this. You see? Audi. Your main idea is, you see, this is called super, right? Super means you're basically contacting the parent class constructor that accepts 4 parameters: the brand, the model, the engine, and the seats. Make sense? And because Audi is always going to be Audi as a constant, so the constructor of Audi, it doesn't require the Audi brand name over here, right? It is always going to be the constant. So that's why we did that. Okay. Now this part is done, but we are getting some problem. What problem? The problem that we are facing here is that there is no method here called get brand and get model. You remember, there is no method over here because in the car class, I removed all those methods. You see, get brand and all that is removed. So let me do this. Let me get back those methods. Just the get part, not the set part. Setting of the value is happening through the construction. Setting the values inside this data member, it is happening through the constructor. Okay. But getting of the values, that can be done. That can be done with get methods. So we can just simply copy select the whole thing. Source, generate getters and setters. Just say select getters. All right. And you can even say protected. Protected means, okay, I haven't spoken about protected, right? Okay, let's talk about protected. You see, I'm going to create some methods and I will be giving the access specifier to these methods with protected access. Let me show you that. So let's look at them. Over here. Okay. What is protected? Look at this method first. String brand get brand. So if you call this method, basically it means that you're going to get back the value of brand or model or get engine or set get seats. That's that is what is happening here. However, these all are protected. Why protected? Why do I need to have a protected here? Protected means the child class will be having access to these methods, can have access to this method. Public means everybody can access the get brand method or get model method. Protected means the child class can have access to these methods. So Audi is the child class of car class, and it is having the access to get brand and get model, no problem. There is also one more thing about protected. Okay, let me first fix the problem with the Mercedes as well. Mercedes, it is saying complaining add constructor, so we did that. And here we don't need to specify the Mercedes in the brand name. We'll remove that and we'll just say this as Mercedes, right? Exact same thing. No difference. Okay. Now the error is gone. If you remember, I spoke to you about default access specifier, if you remember, right? And I said that in default access specifier, both the classes from where you're accessing and which class is holding the default access specified element, those two guys or those two classes needs to be in the same package. I gave you that example. If you look at this one over here, let me close all of this. You see controller. So controller is trying to access this guy, which was a default access. If you look into it, this is a default access guy, right? And this guy is now creating a problem in line number 27 saying that is not visible, right? So if I move the test, if I move the controller into the Java test class like this, then the problem will be gone. Yeah, it is. The problems are happening for others because these are all, I think, what is this? These are all. Oh, these are also default guys, so it is having a problem. So what I'm trying to say here is that you see, Mazda seats is not having a problem anymore. Why? Because seats is a default access, is having a default access. So basically, it means that anywhere if you're trying to access a default element, from where you're trying to access it should be in the same class where it has been declared, right? So that's a default access. Now, that is not the case with, I will put car over here. Okay, all the errors are gone. So I will go back to Mercedes, and you can see in protected mode, every one of them are protected, right? Now, if I create a new package, called a new package, I can just say test package, simple like that. And you can see now I move the Benz to test package. And look, Benz can still access get brand. So what did we learn about this? Learn from this? So what we learned here is that even if the parent class and the child class are in two different packages, if you have a protected entity inside your parent class, the child class will still be able to access it. So changing of package is not going to really be hampering that or impacting that. Correct? That's what you have to understand. Good, fine. So this is the situation with constructor and protected. Okay. Basically, it means that as soon as you are creating the instance of the car class, you are specifying all the information with it. Okay. Let's move on to other things. Method overloading, method overriding, runtime polymorphism. Okay, very important concepts to understand. Once we are done with that, let me check out what else we have. So class 9 is about that. And locator strategies. I will start this next week, next month, because this is going to be again another rough ride. I don't think you can take so much today. I will simply complete the week 3 today with the runtime polymorphism, and then we'll come back next week and we'll talk about XPaths and absolute XPath and relative XPath, which is very important. I will enable week number 4 this time, obviously, because in week number 4 we have described about XPaths in much greater detail. So watch them, come back to the class, and we will talk about that in details. And then obviously I will cover up the last video over here. Okay. So we understood about constructor. Now let's go to overloading. A very simple concept, actually. What is overloading? I have actually given you an example of overloading some time back. Let's see it here. There's Java. Yeah. Okay. Perfect. This is called overloading, ideally. If you remember this simple example. Look. So what I was doing here, I was adding numbers. So there are these 3 methods in this class called add numbers, and add numbers. Okay. You are not allowed to keep duplicate methods in a class. If you do that, you will immediately get the error saying duplicate method not allowed. Okay, void add numbers. And if I do this just like that, immediately I'm getting the error message saying duplicate method add numbers in type test methods. In test methods class, there's a duplicate method called add number. It is considering, Java is considering those 2 methods as duplicate methods. However, Java is not considering this method and this method as duplicate methods. Why? They are different because they have different signatures. What do you mean by that? Signature? Signature meaning the parameter. In line number 27, the add number method is having no parameter whatsoever. And the next one is having 2 parameters. And the next one is having a var args parameters. That's where they are different from each other. And this concept is called as overloading, meaning the name of the method will be same, but the parameters will be different. Different in number, different in type. If I have another add number where I'm saying that I'm trying to add a string with a number, like this, let's go string A, right? You cannot add a string to a number, right? But if the string is actually, okay, let's say this. Let's run this program. Add numbers, string and B and number, right? So I'll go like this. I'll go test methods. Test methods dot add numbers. Sorry, my bad. Test dot add numbers. Test dot add numbers. Okay. Here I'm asking string and B. So let's go with the string as, I don't know, maybe Sovic. Okay. And let's give the value as 9. If I run this, the information that I got was Sovic 9. If I give the value as 9, my expectation will be that I will get 9 plus 9, 18. And if I run this now, I'll get the value 99. Why? Because simply it is concatenating two numbers. That's wrong. Correct? So this method is going to have a different implementation. It is of string, right? So instead of saying A plus B, I would do string, integer dot parse int. So I'm parsing the value of A, which is actually a number, into an integer. So you cannot parse Sovic to an integer. That's not possible. But if you can parse a 9, which is a string, to an integer, you can do that. And if you do that, then if you run this now, you get the value 18. That makes sense. Correct? So basically, you see this very clearly that I have methods. My parameters are different from each other, right? And that is how they are overloaded. Okay. Overloading is also called as polymorphism. Polymorphism means poly means what? Poly means multiple, and morphism means shapes or types. So multiple shapes or multiple types, whatever you can think of. So that is basically your overloading in place. Now let's try to understand about overriding. Overriding is awesome. So let's go to the diagram. That will be more interesting to show. Yeah. Method overriding. So look, overriding is a feature that allows a subclass or a child class to provide a specific implementation of a method that is already provided by the superclass. What do I mean? Look here. There is a class here called parent. In the parent class, there is a method called show. Okay. Child class is extending to parent class. And in the child class also, I am adding another method called show, which means the child class show method, sorry, the parent class show method is overridden by the child class show method. Okay, let me give you an example. Just give me 2 seconds. We'll take the example of the car class here, right? And then we will show you. In the car class, you saw that for Mercedes and for Audi, we have specific starting mechanism. Start with proximity, start with fingerprint scanner, right? So we can actually create a overridden method out of it. Let me just give me 1 second here. Okay, so let's see. What I'm trying to say here is that let's go to leave this. Click number 4. Okay, so we have I'll put the Mercedes here. All right. Now there is a relationship between Mercedes and car. It is already there. In the car class, we have a method called start. Correct? We have a method called start. Now, child class Mercedes can override the same start method like this. Instead of keeping a separate method like start with proximity sensor, I can just say public void start car. Look, this start car method is coming from where? From the parent class. And then I just copy the whole piece, paste it here, remove this guy totally, not needed at all, right? And you can see that it is overridden because there is a triangle next to it now that clearly says overrides cards.car.startCar. So inside the cards package, there is a car class. Inside the car class, there is the start car method. So that is being overridden now. How cool is that? Yeah. And exactly the same thing can be done with Audi. So I go Audi, sorry, public void start car. Instead of keeping a separate method, I can leverage my original start car method coming from my parent. That's the whole story about it. And now what? Now if we go back to car tester, and I just commented everything out, I can uncomment this whole block. And obviously it is creating problem because none of them are here. So just remove. I just go and copy this whole thing, paste it here. And there's an error here, right? That's why it is showing. No problem. Oh no, because of this one. Okay. And why are you having a problem? Okay. This is not needed. Okay. And the Audi is let's not do with the Audi. Forget it. Okay. And I just go and just say Benz.startCar. Benz.startCar. Right? And if I run this now, look, it's starting with proximity sensor. It is not calling the original start car, which was just this stupid thing. Brand model starting. It is not calling that. It is calling the specific one that I declared for the child class. That's the whole idea about overriding. Is this clear now? Understandable? Yes, no? Okay. Afi, are you getting it?
Yes.
Okay, good. Perfect. Good stuff. Good stuff. Good stuff. So then let's move on to the next part, which is going to be runtime polymorphism. Okay, which is also a very important concept. Just a second. Okay. So runtime polymorphism. Runtime polymorphism means what? One minute. I'm thinking of something. What kind of example can I give you here? Okay. Okay. We'll take the example of the car class itself. And we will see. Okay. So, every time when I'm explaining things, I have to think about a story to really talk about. So let's just say car tester. All right. Let's remove this, or I'll just create a new one. New class tester or class car controller. Car controller. And then let's try to understand something. So what I'm saying here is that there is a possibility, I mean, not possibility, but if you look at the car tester, right? You see that every time if I have to call method like start car, accelerate car, stop car, right? For Benz, I'm calling it separately, like Benz dot start car, accelerate car, stop car. And for Audi, I'm calling Audi dot start car, accelerate car, stop car. I'm doing that, right? I'm trying to call these methods individually for a specific object. What if we can make things a little bit better to understand? Like we can make things a little bit better to, or we can optimize this code. Is there a way we can optimize this code? Like, I don't want to call the start car like 2 times or accelerate car 2 times, stop car 2 times. I don't want to do that. But still, I want to make sure that when the start car is getting called for Benz, it is being called for Benz only and not for Audi. And the same thing for Audi as well. Instead of writing the line multiple times, can we somehow optimize it? That is the whole idea. Can we somehow optimize it? So yes, we can optimize it. Why we can optimize it? We can optimize it because of the runtime polymorphism concept. Meaning what? Meaning, so we are talking about the Mercedes class or Audi class. Audi, right? Actually, I just copy the whole piece of Mercedes, for example. Okay, let me just show you something. Benz equals new Benz, and I have given the parameters. Good stuff. Now, let me do a sysout on this. Sorry. Let me do a sysout on this. And we will say Benz as an object dot, let's say, get class dot get type name. Let's run this. Okay. 1 minute. It is not showing what I want to see. Then start get class dot get canonical name, get class loader. I'm just trying to get some more information about this class, and that's why I'm looking at the right method, which can give me that information. Simple name underline the class as given the source code. Get type name. Return an informative string of the name within that. This annotation, no. It is not giving me that information what I'm looking for. Is of type, let's see. Is get component type. Let's see this guy. Let's see this guy. I'm trying to print out our information. I'm not sure if it gives me that or not, but let's see. Now, okay, leave it. Leave it. Okay. Mercedes. What is Mercedes? Mercedes is a class which is extended to the car class. That's what we have understood. But in other way, we can say that Mercedes is of type car class. We can say Mercedes because Mercedes extends to car, therefore we can say Mercedes is of type car class. Is of type car class, yeah. With this information, what will you do? With this information, we can write something like this, something that I have never discussed with you before. We always have created an object of a Mercedes class in this fashion. Mercedes-Benz equals new Mercedes. That's how we have done it all the time. But now we can do it in a different way. We can create, let me create a string first, string car or a string brand equals to Benz. Okay, like so. And then we will do something like this. We'll say car. I'm creating an object of car called car auto equals to new Mercedes. Do you see this? This structure you have not seen ever. I mean, I haven't discussed about this before. You see, I'm creating, so this means what? This means that I am creating an object of car pointing to Mercedes or referencing to Mercedes. Sorry about that. Creating an object, an instance of car, instance of car car referencing to what? Mercedes. This line exactly means that. Now, why do I care? Why do I need to do this? Is the next question. That is exactly where I'm coming in right now. So let me clear this. Let me actually make this whole thing null. All right, null. And what I'm going to do is I'm going to write an if statement. I would say if if brand dot equals ignore case is equals to Benz, then I want to do something. Else if Audi, then I want to do something else, right? So auto, right? And then what do? I do auto dot start car, auto dot accelerate car, auto dot stop car. Okay. Auto is an object of car class. So obviously I have access to these three guys. No wonder. Okay. Now I can write something like this. I say if it is Benz, then I'm creating an object of Benz like this, right? If it is Audi, then I create an object of Audi, new Audi, and we give A3, we give 2.2 and 4-seater. Right? So basically, what I'm trying to do is, what I'm going to say here is that depending on the user input, whether it is going to be a Benz or it's going to be an Audi, depending on the user input, ideally, at runtime, when the execution is in place, right? When the code is getting executed, depending on the user input, the instance will be acting according to the, according to what type of object got created. This is called as a runtime polymorphism. Now look, I'm said Benz. If I go and create the object of Benz now, right? If I run this now, Benz starting with proximity sensor. Do you see that? It is not picking up the information from the car class where it was just starting. No, it is putting the information accurately. If I just say Audi, it will work for Audi as well. Look, this is called as a runtime polymorphism because at runtime you are creating an object of a parent class that is referencing to the child class depending on the user input. And that reference of the that instance of the car class is very much activating as if Mercedes is calling start car or Audi is calling start car. You understand? If think about it, only if Audi calls Audi.start car, only then this is supposed to be printed, otherwise not, right? Otherwise not. But in this case, Audi is not calling until and unless I'm executing the program. By looking at this program, you can very well see that basically the car is calling start car, not Audi. That part happened here. And this was able to happen. This happened because Audi is of type car. Audi is a child of car. In other words, Audi is of type car. That is very important for you to understand. This is called runtime polymorphism. And whatever I showed you guys right now will probably not have a direct impact on Selenium WebDriver, whatever I will be covering up in a couple of weeks from here on. You will not see a direct impact on it. Why you will not see? Because I'm not in that framework designing zone. When I start developing the framework, you will see that I will be using all these concepts. So the only request that I have for you at this time is that whatever I'm showing you, whatever examples I'm showing you, at least try to practice them. And whatever the assignments I'm giving you, try to practice them as well. The only reason for that is that you're going to build up your foundation even stronger. When I start talking about the framework designing, it will be easier for you to, it will be much more easier for you to understand that why am I writing, what is the idea behind creating a structure like this. All this concept I will be using in detail in all the frameworks that I will be talking about, but you really have to understand this. Okay, so this is week number 4 where we have discussed it. So please complete the assignments. I think week number 3 should have all the assignments, so try to complete them. And I think that's where I can close my class today. If you don't have a question, then I can close the class today, and then we'll come back next week. We will be completely working on locators, which is very, very important. A lot to learn from here on. So yeah, if you have a question, Steve, please go on.
I guess this isn't related to the particular class. I just had sent you a couple messages on Slack earlier this week. I haven't heard any. I don't know if you've unlocked class week 4 for everybody, or if it's just me that hasn't got access to it yet.
I have informed this Steve last week itself that week number 4 is going to be enabled now today. Week number 3, I told last week, right, that I'm not enabling week number 4. We will cover up week number 3 completely, and then we'll go to week number 4. So now today I will enable week number 4.
And also I messaged you about you sent me a DocuSign through email, but it has a wrong client name.
Oh, my bad. I will change that. Sorry about that. Yeah, I will change that.
Thank you.
Thank you so much. Perfect. And guys, if you are not able to reach out to me, or if you see that I'm not answering in the Slack, sometimes I miss it. So please contact me in my WhatsApp. My WhatsApp number it's there in my website anyways, but you can just drop a message over here. I'm just writing it down. That's here. Okay. I have sent the WhatsApp number, so please take a look into it. Okay. And just drop me a message if you're not getting an answer anyways. So that's with that. But any questions about whatever I have spoken today? Afi, any questions?
No,
Okay. How are you practicing? How's it going on so far?
good. I'm getting better at it though.
Okay. Good stuff. Good to know that.
Yeah.
Kester, how's it going?
It's going good.
Okay. Okay. Ramon, I know these concepts are a little bit repetitive for you. or is it a refresher for you? What do you think?
Yeah, it's good to refresh
Yeah.
these concepts.
Yeah, good stuff. Ahmed, what about you? Are you getting time now? Ahmed, are you there?
Can you hear me now?
Yeah, I can hear you. Yeah, go on.
Yeah, it's okay. I'm better.
Very good, very good.
Mm.
Okay, guys, let's come back next week. I'm enabling week number 4. So please go through it and come back to me. Okay. Thank you. Have a
Okay,
great week
thanks.
ahead. Thank you, guys. Bye-bye.
Thank you.
Bye bye.